Radio TV Phono Nut here, and the video footage that you're about to see is not recent. This is one of those repair videos that somehow made its way into the computer a long time ago, and I never got around to putting it all together, and that's probably a good thing because we had some musical content at the end of this video that would probably trigger content ID, and after the hoopla we just went through with the music channel and getting a copyright strike that apparently carries over to this channel, I'm watching my P's and Q's as far as that. So what we have here is an Audiotronics Model 300E vacuum tube based classroom record player from about 1968. This is towards the end of the vacuum tube era for Audiotronics. In fact, they were already making transistorized models when this was made. This was an economy model that uses a 4x6 speaker, and the amplifier uses a single 6T9 vacuum tube which contains a triode and a pentode in the same envelope and a solid state rectifier. This had a pause control on it at one time, but somebody broke that off. But anyway, in the video footage to follow, you'll see how we repaired this, but I'll play you a few seconds of audio just to show you how it works, and hopefully we won't get any kind of copyright content ID crap. Well, hopefully that was short enough that it won't trigger anything, but who knows the way they're getting today about stuff. Alright, that last segment was right at 7 seconds. And if that triggers any kind of content ID, then y'all can just kiss my behind and learn what fair use means. We've got some early Ray Charles here from probably the early 1950s. So yeah, there you go, the little Audiotronics school phonograph from 1968. And I think these things are starting to decrease in popularity, and I think a good reason for that is because the static plug-in 89T cartridges that these use are becoming scarce and expensive. And don't waste your money on the newly produced fan steel ones. I did. I'm not happy with the results. I won't be doing that again. They seem to have lower output than the originals, and they don't seem to sound as well as the original ones. And on the subject of lower output, the amplifiers in most of these school record players were designed to perform at their peak with a cartridge that puts out about 1.3 to 1.5 volts. So if you go installing a generic ceramic cartridge such as a Chuodenshi ZZ800 or a Varco TN4B that puts out about a half a volt, it'll play, but your volume level will be a good bit lower, and you won't have the tonal quality that you had with the 89T. And part of that is because most of these amplifiers use a loudness compensated volume control, and they need to see that hot output cartridge. They don't do too well with lower output cartridges. Now, I could build a preamp stage. That's something I need to work on one day, so that we can use a more conventional type of cartridge, because I seriously doubt that anybody will ever make an 89T that's decent quality. And even if they did, it would cost a lot more than what they did 30 years ago. I remember up until the early 2000s paying about $5 a piece for them. Today you're going to pay minimum about $27 for the fan steel version. That's plus shipping, by the way, for something that's really not all that great anyhow. So enjoy the footage. I'll spoil it for you. It needed a filter capacitor, but hopefully you'll get something out of the upcoming footage. and there'll be more to come later, I hope. Well, I'm glad I reviewed the footage because I misspoke. I said this had a 4x6 speaker. It actually does not. It has a 4x10-inch speaker. And before any of you go thinking that I'm an ultra tightwad by expecting good quality 89T cartridges for $5 a piece, yeah, it would be nice, but I know that's not possible anymore. And honestly, I wouldn't mind paying $20 or $25 for a good one. And I mean one that's decent quality, that sounds like the old Statics did. And I mean a version that has a diamond LP tip on it, not a sapphire. And a 3mm tip on the other side for 78 playback. But I certainly have a big problem with paying $20+ for something that doesn't perform well. Alright, so I think that's all the corrections that I need to make, so enjoy the footage and more to come later. Radio TV Phono Nut here, and we have a last gasp tube type Audiotronics 300E classroom record player from 1968. This uses a solid state power supply and then a type 69 Compactron tube, which contains a triode, driver stage, and a pentode output stage in the same envelope. The person I got this from claimed the speaker was bad because they said it had weak audio, and I suspect the audio they were hearing was just needle talk. Well, I'm not getting any audio at all. As you can hear, nothing whenever I scrape the needle. And I've already checked the continuity of the speaker voice coil. It's good, as is the secondary winding on the output transformer. So now it's time to test voltages and see where we are with that. Alright, I'm set to measure DC volts. Let's look at the output of our rectifier here. What do we have? Not a thing. Alright, let's move to AC volts and see if we have anything going into the rectifier. And we do not, so we're not getting any AC here, and something looks very suspicious here. We have a red wire going to the input of our rectifier, and that red wire goes up what looks like the output transformer. Normally, the red wire would be where your B+ enters into the transformer. So has somebody been in this record player monkeying around? No, doofus, that's your secondary winding coming out of the power transformer. Alright, I'm looking at our leads coming off the power switch. One goes to the transformer, one goes to the motor. And I don't know what this melted crap is on this lead here, but we need to look into this. Alright, our fuse is blown. And I come to that conclusion. Well, first I noticed there was no filament in the tube, and the way this is wired, only the transformer primary winding is fused. The motor is not fused. So if the fuse blew, obviously the motor would still run, but the transformer is not getting any juice. And as you can see, we're reading 53 ohms across that fuse, so it's blown. Now, knowing that fuses don't blow for no reason, we need to find out why it blew. Alright, diodes are good, but I have seen filter caps in these get leaky and cause the fuse to blow, so I have a 60-watt incandescent bulb in place of the fuse, and let's turn it on now and see what takes place. It's not even lighting up. So that's a good sign. Alright, let's see what kind of B+ voltage we have. Alright, we're still not getting anything, and the reason being is because our bulb has an open filament. I guess it got knocked around too much. So let's find another 60-watt incandescent bulb and retest. Alright, I dug up another light bulb, so let's try that one more time. Whoa! That's pretty bright, isn't it? Alright, our B plus is slowly rising, so I think we probably got a leaky filter cap here. Despite that, the amplifier is working. Okay, so our B plus is rising. We're up to about 125 and creeping up, and our bulb is gotten a little bit dimmer. So yeah, that cap was leaky and is reforming to some degree, but that cap needs to go, I do believe. Alright, we're now up to 146 and rising. Bulb is getting a little dimmer. So yeah, it's just that electrolytic cap was leaky and is reforming, and the light bulb is limiting the current. I suspect what happened was somebody found this record player after it hadn't been turned on in heaven knows how long, and they just plugged it into 120 and turned it on, and with the filter capacitor being old and dormant and hadn't been used in years, it initially drew too much current and popped the fuse. Now we're up to 162 volts, 163 volts. So yeah, like Shango was trying to explain on his GE Color TV video, the Variac just limits the voltage. The light bulb, it limits the current, because the more current the load places on the light bulb, it's just going to glow brighter. Or let me put that another way. With the light bulb in series with the load, this will sound more correct. With the light bulb in series with the load, the more current is placed, is being drawn by the load, the brighter the light bulb is going to be. And this cap is starting to get a little warm to the touch. Of course, a lot of that is, some of this is due to heat being radiated off this tube, but I think some of it's just this cap is getting a bit warm to the touch, which is normal for a leaky cap. Now what's our voltage? 177. And the bulb is getting dimmer, which you may not be able to tell that as much on camera. 180. Now, would I trust a reformed cap for something that we're going to put into service? No, I would not. Now, if this was just some crusty resurrection, it wouldn't bother me. But for something that we're going to put in service, that cap needs to be replaced. Because I just, capacitors are cheap enough, and I just don't trust a reformed capacitor to hold out for the long haul, so to speak. Of course, with our light bulb in series, our B plus is going to be lower anyway, but we started out with a severely leaking capacitor that caused almost maximum brightness of the bulb and about 50-something volts B plus at the cathode of our rectifier. And then as the cap started reforming, our bulb got dimmer because the load was drawing less current at that point, and we now have 190 volts B plus. Yeah, our amplifier is working. So what I want to do is turn this off for a little while, let everything cool down, and then we're going to turn it on again and see what takes place. But before I switch it off, let's make one more B plus measurement. 197.5. That's close enough to 200 for government work. And in this case, our incandescent bulb is simply my dim bulb tester that I placed a short across the receptacle where we would normally plug our load into. So I have a short placed across that, and then I have the AC cord on the dim bulb tester clipped across where the fuse would go in the amplifier. And remember, the motor is not part of the equation here. Are we over 200 volts yet? We're at 200 volts. Now on another note, that 300E record player, Audiotronics used that model number for years. I think it first started in the early 60s, and I believe that version used, what was it, a 6GW8, I believe, which was a 9-pin miniature tube that had a triode driver stage and a pentode output stage in the same envelope, and then they went to the 6T9 Compactron tube, and then they went to a solid state amplifier that was wired point to point on terminal strips, and the output transistor was riveted to the metal motor board. In fact, on the one we're working on, you can tell that they were already making transistorized versions of that record player, because the motor board is stamped for the output transistors to be mounted, but of course there's no transistors there because this is a tube unit. Likely just an effort to get rid of the excess tube inventory. Here's a picture of an older 300E I had, and you can see the components on the terminal strip there, and you can't see the output transistor for the motor in the way, but it's there on the motor board itself. Alright, here's another picture of it. You can see it better. Let's see. Yeah, there's our output transistor right there, and then there's a cutout for another transistor. I think some models might have had 2 transistors there, but this one only has 1. Here's a picture of a newer 300E that I used to have. I think by about 73 they abandoned the point-to-point wired amp and completely redesigned the cosmetics of the record players. Went from a metal tone arm to a plastic tone arm, and went with a printed circuit board based amplifier, and I believe that 300E model designation was used up until about 79 when they redesigned everything again and went to the model 304E for the economy models. So when somebody tells me I've got an Audiotronics 300E record player, that don't tell me a whole lot. It could be one of several different models. It was made over about a 15 to 20 year period. And here's a schematic for that amplifier. As you can see, we have our cartridge and volume and tone controls coming in here, feeding the triode portion of that tube, and then the triode portion is capacitively coupled to the pentode portion of that tube. I think a 6T9 is basically the equivalent of a 6AQ5 and a 6AV6 is separate tubes there. And then here's our input here. We have our AC coming in through here through a 1/2 amp slow blow fuse, and you can see the motor gets its power before the fuse. And then coming off of the secondary of the transformer, we have one winding to provide our 6.3 volts for the tube heater, and then we have a 250 volt winding that provides AC voltage through these 2 diodes in series. I'm not quite sure why they had the 2 diodes in series. Each diode would drop about 0.7 volts. You'd have about 1.4 volt drop across those 2. The main reason I can think of that they might have done that was for safety reasons, in case one diode shorted, then you had another one to fall back on. But anyway, we come off the diodes here, and we have 290 volts B plus under normal circumstances with a good capacitor, and of course no light bulb in the equation. So we have a 40 microfarad, a 25 microfarad, and another 25 microfarad as our B plus smoothing filters, and then we have a 50 microfarad that goes up here for our cathode bypass for the audio output tube. And of course all of those will be replaced. We'll leave the old cap in place for appearance purposes and just mount a terminal strip to the underside of the chassis and mount our new capacitors under the chassis there. And like I said, caps are cheap enough. There's no reason to trust a reformed cap on something that we're going to put into service. Yes, it might last for 10 years, but then again, it might not last for 10 minutes. But yeah, this was just a case of this had been sitting up for umpteen years. Somebody found it, plugged it in, turned it on. After decades of the capacitor not being used, it got banged with high voltage. It acted like a short, drew too much current, and popped the fuse, and that was that. I'm just glad whoever tested it didn't decide to go further and find the blown fuse and bypass it with aluminum foil. But using the light bulb in place of the fuse, that just acted like a current limiter to allow this capacitor to reform and come back to life, but we're going to replace it very shortly. It always amazes me how well these classroom record players sound to be as minimal as the amplifiers often are in these things. As you can tell, there's not a whole lot to this, but I will tell you one thing. I've had people tell me when it comes to the 89T cartridge, just replace it with a fan steel P226. I've done that on mine, and it was a little weaker in volume, but I didn't notice that much difference. Well, evidently their ears must not be the same as mine, because I've tried replacing these cartridges with a P226, which is the equivalent of a Varco TN4B, and they just don't sound right to me. They sound very tinny and not nearly as much volume, and that's because the P226 has an output of a 0.5 volt, and the 89T has an output of 1.3 volts, and this unit has a loudness tap on the volume control, as you can see here, and its purpose is to boost the low frequencies at lower volume settings. And when you don't feed these amplifiers with a hot enough signal, then basically the loudness compensation becomes ineffective, and that's the reason they sound weak and tinny. So if you're going to replace this with a lower output cartridge, then you're going to have to design some kind of preamp stage. Solid state would probably be best to go between the cartridge and the amplifier input, and that's something that I'm going to have to do because 89Ts are not being made anymore. The ones you find are not $5 a piece anymore. They're more like $30 and up. And in my mind, that's just too much. If they were still being made and $5 a piece, then I wouldn't worry about it. When one failed, I'd just go to the parts house and buy one and replace it and be done with it. But the parts house, we don't even have one anymore, but they haven't stocked any since about 2001. I bought the last couple they had for $5 and change a piece, and they said enjoy them because there's not going to be any more. They said the school district no longer uses record players, and PRB is no longer offering the cartridges, so we're no longer going to be stocking them. And that was over 20 years ago. Alright, it's another day. This cap's had plenty enough time to, shall we say, cool down. And I'm going to turn this on, and theoretically what should happen under normal conditions is this light bulb should very briefly glow bright and then dim back down. That's because whenever a capacitor first sees voltage, it acts like a short momentarily, and then things stabilize and then everything's okay. But that's why this thing uses a slow blow fuse to compensate for that brief inrush current there. So let's turn it on and see what we get. Alright, 130 volts and rising. Light bulb's still a little bright, but yeah, it should not take the B+ voltage this long to climb up. So yeah, this cap, after it stayed off overnight, it is starting to fail. So we're going to replace this capacitor. and then we're going to power it up again under the exact same conditions with the light bulb and see what it does. Alright, I'll remove the tube, which should take away the load. So we're going to turn this on and see what it ramps up to with no load on it. 160 volts and rising. And that's our light bulb. And now with the tube out, not producing any heat, I can more accurately feel that capacitor and see if it's getting hot to the touch. It's slowly rising, and as it rises, the bulb is getting a little dimmer. Yeah, this voltage should get a lot higher than what it is with no load on it. We're not getting warm yet. See, the bulb is getting even dimmer. Voltage is climbing. Capacitor still cool to the touch. I'll kill the camera. There's no need in us watching all this. The bulb is a good bit dimmer now. Okay, we're up to 184 volts and the bulb is almost extinguished. Now let me say, the proper way to reform a cap is to use a variac in conjunction with the dim bulb, but I really wasn't aiming to reform the capacitor in this set. It just happened the way it did. All I was trying to do was just substitute a load for the fuse to determine what was wrong. Alright, this capacitor is starting to get slightly warm to the touch now. Just barely noticeably warm. And we're up to almost 300 volts, as you can see. 297, that's close enough to 3 for government work. Okay, this thing is starting to get a little warmer now. Now we're up to over 300 volts. I'm just asking for trouble, aren't I? Alright, so what I'm going to do now is turn it off, and theoretically with the tube gone and no load on the B+ supply, that cap should retain a charge for quite a while, but I suspect what's going to happen here is it's going to discharge through its own leakiness, so to speak. Yeah, this thing's getting warmer, so let's turn it off and watch the meter. Yeah, you see how rapidly it's discharging there? So yeah, the capacitor is, shall we say, discharging through its own leakage. Think of the leakage as like a resistor in parallel with a capacitor. That's the best way to think of it. And the resistor, being the leakage, is pulling the charge down off of this cap. So now it's time to take this cap out of circuit, put a terminal strip right here, and put some fresh new ones under there. And just for fun, there's the schematic for those who might want to see exactly what the circuitry looks like. I know I already showed you a schematic on that I had on the computer of another model, but I'll show you the actual schematic that's pasted inside of this one, it might actually be a little bit different than what that schematic I showed you was, but there it is anyway. Alright, it's about dark, so we're going to have to stop. I got sidetracked, and this looks a little uglier than I wanted it to because I didn't have a 40 microfarad. All I had was a 33, which would have probably worked fine, so I ended up putting a 10 in parallel with a 33. But I'm probably going to pull that out because I don't like how that looks and it touching that resistor. So let's turn it on and see what happens. Alright, hopefully I didn't screw nothing up. Let's see. Alright, bright light, dim light. And our voltage is rising. Well, some of that has to do with the light bulb. And of course, as the tube conducts, well, you know what? It might work if I'd put the tube in. That'll illustrate a point with me forgetting to put the tube in. Turn it off. Well, we lost our light. Alright, it's discharging. Alright, tube. Where's the tube? Okay, take two. Alright, 327 volts, and it'll drop when the tube starts conducting. And then as the tube starts conducting, our light gets a little bit brighter. Alright, let's see if we have activity from the cartridge. We do. Now, I still need to replace that cathode bypass cap, but that can wait till tomorrow. Alright, I've got the bulb removed. And we start out at 360 something volts, unloaded, and under load we've got about 300 volts. And that's about what we should have. Actually, I think it's a little high, but we've got to take into account today's higher line voltage. But we have 306 volts there. So tomorrow we'll find a fuse, get that bypass cap for the cathode replaced, and that ought to take care of our amplifier. Alright, I cleaned up my mess a little bit, put the capacitor down here out of the way where it wouldn't look quite so bad, and then I replaced our cathode bypass capacitor here, so we're almost ready to put this back together. I replaced that one grommet on the motor that was rotten and crumbling apart. Technically I should have replaced all three, but the other two are still in pretty good shape, and I'm kind of running low on grommets, so I'm trying to go sparingly there. This spindle had some dried up grease in it, so I took that out and re-lubricated it. Took the motor apart and oiled it while I was at it. So we need to get a new rubber washer for this, but right now that'll have to do. That looks like something that come off of a caliphone. They used to have some weird looking cork looking spacers under their tone arms, and I figure that's what that came off of. I don't know, but anyway, I'm about ready to put it back together and put this thing into service. But as far as reforming capacitors, I know I didn't make myself as clear as I should have earlier, but a lot of people are getting on eBay and paying hundreds of dollars for those old school Heathkit and similar capacitor leakage testers, and they're using those to reform capacitors. Well, if you choose to do such a thing, then there are cheaper ways to do it besides spending hundreds of dollars on an old school cap tester. All you really need is a variac and a half-wave rectifier and a dim bulb tester, and that's really all you need. Just connect the dim bulb tester to the variac and connect your rectifier diode to the output of the dim bulb tester, and then connect that to your electrolytic capacitor. Start it out at about 0 volts and just, well, and connect a DC voltmeter across the cap and just gradually keep raising the voltage over a course of several hours up until you get it up to the working voltage of the cap, and then your mission will be accomplished. I think I did a video not too long ago showing that procedure, and I can tell you, you can pick up a used Variac or possibly even a new Chinese one for a lot less money than spending $300, $400, $500 for one of those old school cap checkers. As far as this broken pause control, there's not a lot I can do about that. As you can see, everything is riveted into place, and I don't have the parts anyway. This particular type of pause control was sort of klutzy, and I feel like that was broken off intentionally because they were having problems with it, so they just broke it off to... Most likely usually what happens that for some reason the tone arm, when you put the tone arm on the rest, it's supposed to press down on the pause control lever and disengage the idler wheel, but they never usually line up like they're supposed to, so I feel like somebody just broke it off and just decided not to worry with it. But for what I'm going to be using it for, a pause control is not a big deal anyway. And that was mainly used in classrooms in case the teacher wanted to pause the record momentarily for class discussion or whatever, and then when he or she was ready to resume, they could just start it back up again. So, but I guess that's about all I've got for this one.